Hello, this is Chris White of the National Weather Service Office and NASA Sport in Huntsville, Alabama. And today I'm going to be demonstrating the application of the Nighttime Microphysics RGB, especially over the Alaska domain. The Nighttime Microphysics RGB is especially useful for distinguishing low cloud phenomena such as stratus and fog from other types of clouds. Typically, in the Nighttime Microphysics RGB, these types of clouds, the low clouds, such as stratus and fog, will appear as shades of light aquas or light grays, as seen here in parts of south central Alaska, or perhaps light oranges and light yellows, as observed here in interior and northern parts of the state. The differences in the colors is due primarily to changes in temperature, which are associated with the 10.8 micron band, or the blue color component of the RGB. Warmer temperatures, and thus more blue, usually give rise to shades of light aquas and light grays as observed here, while colder temperatures, and thus less blue, provides generally shades of light oranges to light yellows as observed here in interior parts of Alaska. Meanwhile, high-level clouds such as cirrus generally appear as reds to dark reds as observed here off the northern coast of Alaska and off of the Yukon here in the Arctic Ocean. And likewise here, as seen in this large band that stretches from north to south across parts of the Aleutian chain in the North Pacific. Also notice there is a gap in the high clouds, and some low clouds can be observed here in other parts of the North Pacific, as indicated by these generally light aqua to light gray type colors. So I wanted to show the difference between the Nighttime Microphysics RGB and a standard 3.7 micron channel. And notice that it is much easier to observe the low cloud phenomena and also importantly the boundaries of those low clouds in the RGB versus something like the 3.7 micron channel. So I also wanted to show a quick case of a low stratus and fog development along the north coast of Alaska that then spreads inwards into the interior part of the state. So I'm going to loop through time and notice the development of low clouds here off the northern coast of Alaska. Then by the morning, the early morning hours of the 26th of December 2017, Alaska time, notice then that low stratus have moved onshore into northern parts of Alaska, and that these clouds then spread into the interior further with time. By the morning of December 27th, these clouds have spread much further inland. Taking a look at some of the observations during this period, we can observe that these clouds were impactful to aviation. Notice here that bases were around 400 feet, some observations as low as 300 feet, and also that freezing fog was even occurring in some of these observations. Importantly, the Nighttime Microphysics RGB demonstrates how easy it is to observe these clouds spreading inland over time. By the morning of December 27th, notice that they have spread further into interior parts of Alaska. And notice again, there is an impactful cloud base at 800 feet here along the north slope of Alaska. So this is part of the power of the Nighttime Microphysics RGB, is especially being able to delineate where low clouds exist from where they do not, especially as opposed to other standard legacy type imagery. And also to distinguish these low cloud features from other clouds that may be occurring, such as this case where you can easily see where the low cloud extends, and then you have some other high cirrus cloud feature above that. So that's it for now. Thanks for your time.